In this video, we're going to talk about ray optics. Okay, so the light is nothing but an electromagnetic wave. So far, we learned that from the previous chapter. Light is nothing but a electromagnetic wave. Light travels in a straight line, paths called light rays. So if you look at if you turn on a flashlight, we'll see a light beam. So this whole thing is a light beam. These individual lines are called light rays. Some materials reflect nearly all the light incident on them. Those are examples of metals. Some materials refract the light rays when they incident on them. Those are example water or glass, something like that. Now I'm going to define two quantities. One is theta I. Theta I is called angle of incident. That angle of incident is nothing but angle between the light ray and normal to the surface. And theta R is angle of reflection, that is angle between the light ray and normal to the surface. So according to law of reflection, theta I is always equal to theta R. So here is a diagram. So you have a surface. If a light ray fall onto them with an angle of theta I to the normal, so normal is nothing but perpendicular to the surface. So now if this light reflects, so the light ray, I just draw one line, that one line represents the light ray. So that light ray is reflecting here. So here, according to law of reflection, theta I is always equal to theta R. If the surface is smooth, then the entire beam is going to reflect without any distortion. That is called specular reflection. So if the surface is smooth like this, then all the light rays are going to reflect. The whole beam is going to reflect. That reflection is called specular reflection. Some of the surfaces, they look smooth from far away, but if you look into the microscopic way, it's a rough surface. If the rough surface reflects the individual rays in different, then it will reflect the rays in individual direction. That is called diffuse reflection. So it doesn't matter whether it is specular reflection or diffuse reflection, still the law of reflection is valid. Always theta I is equal to theta R. Doesn't matter whether it is a smooth surface or rough surface, or specular reflection or diffuse reflection. So theta I is always valid. Law of reflection is always valid. Theta I equal to theta R. Here is an example. There are two mirrors, mirror 1 and mirror 2. A light ray is falling on mirror 1 with an angle of 15 degrees. Okay, the question he's asking about, find the theta phi. Okay, the given theta, it's not angle of incident. Remember, always angle of incident is angle the light ray is making with the normal. So this is theta I. Can you guys tell me what is theta I here? So the angle between normal to the surface must be 90 degrees. So can I say this theta I is 90 minus 15, which is 75 degrees. So according to law of reflection, I know that theta I equal to theta R. So definitely, what is this theta R? Theta R must be 75 degrees. Okay, so if that is 75 degrees, for sure this must be 15 degrees. Now here is second surface, normal to the surface. Now can we find this angle? So theta I, let me take that as theta 3. Can we find theta 3 there? Okay, you can clearly see from this right angle triangle right there, this right angle triangle, this must be 90 degrees there, and it is 15, so this must be 75 degrees. So theta 3 must be 15 degrees. So if theta 3 is 15 degrees, that is angle of incident. Theta R, angle of reflection, must be 15 degrees. So if this is 15 degrees, what is theta phi? Theta phi must be 75 degrees. That's one example. Here is another example. There are two mirrors. They are making 135 degrees to each other. So here is mirror 1. The angle between these two mirrors is 135 degrees. Now a light ray is falling on mirror 1 with an angle of 38 degrees. Remember, that's not angle of incident, because angle of incident is always between normal to the mirror and between normal to the mirror and on the light ray. So here is normal to the mirror. Same way, here is another normal to the mirror. This angle must be 90 degrees. Here also this must be 90 degrees. Okay, so what is this theta I, angle of incident? Let me take that as theta 1, so I can take this as theta 2. Theta 1, angle of incident, must be angle of reflection. Theta 2, which is 90 minus 38, which is 52 degrees. So theta 1 equal to 52 degrees. That must be equal to theta 2. So this must be 52 degrees. Now if I know that angle, can I find this? This must be 38 degrees. Okay, so if that is 38 degrees, can we find this angle here? So the total angles in a triangle must be 180. So 180 equal to 38 plus 135 plus, let me take this as theta 3. So what is theta 3 there? So theta 3 is 7 degrees. Now if theta 3 is 7 degrees, can I say this angle must be 90 minus 7, which is 83 degrees. So angle of incident must be angle of reflection, 83 degrees. So what is the phi value here? So which is equal to theta 3. That value is 7 degrees. Here is another example. A dressing mirror on a closet door is 1.5 meter tall. The bottom is 0.5 meter above the floor. So here is a dressing mirror. This dressing mirror is 1.5 meter tall. Okay, and this is 0.5 meter above the ground level. Okay, a bare light bulb hangs 1 meter from the closet door and 2.5 meter above the floor. So a light bulb, I'm assuming that light bulb is a point source. Okay, this is the bulb. Now this bulb is 2.5 meter above the ground level, and also this is from 1 meter from the mirror. Okay. Now what happens? This bulb is going to have a light. Here is the bulb. This bulb is going to produce the light rays, and those light rays are going to reflect all directions. Now the question is, when it reflects on the mirror, so I'm going to draw a few lines, something like that. What happens? These lines, the light rays are going to reflect. Okay, so all we know, angle of incident equal to angle of reflection. That's a law of reflection basically. Okay, so what happens? All these light rays, they will reflect. So probably this will go away, that will reflect. Okay, so the question he's asking about, how long is the streak of reflected light across the floor? So I believe he's talking about, what is this length L2. So the question he's asking about, what is this length L2? So all we know that theta I must be equal to theta R. So if you look at the first triangle, so here is the angle of incident, theta I, that is normal to the mirror. So here is theta I. So first we will find that theta I. So if you look at the triangle, this length is 1 meter, and this length is 0.5 meters. Okay, so can we find, so if a light ray fall on this is the light ray, blue one, it will reflect. Okay. All I care for this angle. Can we find that angle? Can I say this angle theta I is same as this angle theta I? So can I say theta I equal to tan inverse of 0.5 over 1, that tan inverse of that value is 26.6 degrees. So theta I is same as theta R. My theta R is 26.6 degrees. Okay, now this light ray, this blue line, this line is same. Now can we find, all I know this angle, which is 26.6 degrees. So if that is 26.6 degrees, what is this value? That value must be 63.4. okay, so I know this height, which is 2 meters. So can I say sine 60, not sine, I need to take tan 63.4 equal to, I will find this whole length, let me take that as L1 over 2 meters. So from there I can find L1 equal to 2 times tan 63.4, that value is 2, so 2 times 2, which is 4 meters. So the total length L1 equal to 4 meters, but my goal is finding L2. Okay, so now we'll look into the other light ray. So I'm ignoring all these light rays in between, because in between light rays they're going to fall in the length of L2 on the floor. So let me take the last light ray. So here is the light ray falling down, and it will reflect and it will fall right there. Okay, now we need to find the theta I here, angle of incident. So I'm going to draw the triangle separate. So this is 1 meter, and this length is 2 meters, because here I have 0.5 meters. So the mirror is going to start from there. So the mirror length is 1.5, and there is a 0.5 meter gap there. Okay, so all I care for, as long as I find this angle theta I, because this is the light ray. Okay, so this theta I and this theta I must be same. Okay, so theta I equal to tan inverse of 2 over 1, that will give me 63.4 degrees. Okay, so I have theta I as 63.4 degrees. So theta R here, so if I come back to the original diagram, this is theta R, that must be 63.4 degrees. Okay, now if I know that angle theta R, I can say angle here in the small triangle must be 26.6. now I know this height, I know the angle. Let me make this as x. Can I find the x value? X equal to tan theta, tan 26.6 times 0.5. That value is 0.5 times 0.5, which is 0.25 x value. So from this, can we find L2? L2 equal to L1 minus x. L1 is 4, x is 0.25, so it is 3.75 meters. So the light ray, because of the light ray reflecting on the mirror, the light ray is going to fall in the area of, or in the length of 3.75 meters. I will stop this video here, but I will continue solving more examples in the next video. Thank you.